last time we spoke about finding mean, median, and mode from a frequency table for discrete data. Today we're going to be working with grouped data, and it'll only be possible to approximate the mean from that. When we talk about grouped data, we mentioned earlier that it's useful when there's a lot of possible values that could happen, and I want to sort of put it into bins. So if you look at this visible light spectrum down here, there's really a wide range from red down to violet and every color in between. When we talk about colors, though, we usually do bin them. We group them together so that everything to the right of here is considered violet, and then indigo, and then blue. Fitting it into these categories, groups, or bins, whatever you want to call them, to make it easier to talk about. But we actually lose a fair amount of nuance or a fair amount of richness in doing that. For instance, like this color right here would be classified as yellow, and this one right next to it classified as green. Binning is helpful for making information easier to think about, but we often lose information by doing so. And so you can see how that might happen in an example here with Denzel Washington's scores on Rotten Tomatoes. So Denzel Washington has been in 47 movies that have a score on Rotten Tomatoes, and the scores are listed here. One of them miraculously got a 0 on Rotten Tomatoes. I think it was called Heart Disease. Glory got 93. That was back in '89. And then more recently, Fences got 92. Those were his best too. But I could make all these into discrete data, but if you notice, they go all the way from 0 up to 93, and there's only 47 of them. It's pretty spread out. So there's a lot of possible values that they could take on. It's rare for the same to happen multiple times. So grouping them is a good option in this case. And they range from 0 up to the maximum possible would be 100. So I'm making the bins intervals of length 10. 0 to 9, 10 to 19, 20 to 29, the 30s, the 40s, and so forth. I went ahead and put them into the bins for you. So you see that there's one movie with a score between 0 and 9. None are in the teens, 2 are in the 20s, and so forth. The most common range is 80 to 89. We can't say that any of these numbers is the mode because we don't know how many times each of the individual numbers from 80 to 89 happened, just that there were a lot of them that were in that range. So with finding the mean, we're still going to want to do what we did last time. X bar is how we call the mean, the sum of the product value times frequency divided by the sum of the frequencies. But if you notice, we don't have a number yet for X. We just have a range for each X. So we have to make our best guess. I don't know, just by looking at this frequency table of grouped data, what this one score is in between 0 and 9. I know it could be 0, it could be 5, it could be 8, it could whatever. I don't know without looking at the list up here, which I'm not allowed to do. I don't know, I just know that it's between 0 and 9. So I'm going to guess the average. 0 plus 9 is 9. 9 divided by 2 is 4.5. There's no numbers in between 10 and 19, but I'm still going to use the midpoint of those as my best guess. And I'll fill out the rest of these. Once I have all these midpoints in here, I'm going to sort of forget about the score column because those are not specific values, they're ranges. I'm going to pretend that I have a new frequency table right here where the midpoint X is my value and frequency is still my frequency, which means I need to find XF up here to calculate the mean. I'm going to do that by multiplying X times F. So 4.5 times 1 is 4.5. 14.5 times 0 is 0. 24.5 times 2 is 49. So I'm just taking the X column, multiplying by the F column, and here's what we get for that. I'm going to note that in most of these cases, the midpoint and the midpoint times the frequency were not whole numbers. It's impossible for a single movie to have a score of 94.5, but that still is our best guess. It's in the middle of what it could possibly be. So we have our XF What we have to do now is add all these up. And when you do that, you get 3141.5, which you may notice looks uncannily like 3.1415 ... which is equal to pi, which just proves that Denzel is a very well-rounded actor. So, bad jokes aside, when we put in what we have now, the sum of xf is our 3141.5 over the sum of f, the sum of the frequencies, 47 movies total. We get to 3 sig figs, 66.8 as the average Rotten Tomatoes score. The actual mean, if you did not group them, if you just use the actual numbers, would be 66.2, which is actually pretty impressive. I took these 47 movies, I put them into pretty big bins, right? A movie that scores a 70 and a movie that scores a 79 aren't that close to each other. I just guess that they're all in the middle of the interval, in the midpoint there, and my average overall was very close. So, because I use bins of this size, it's not perfect, but it's not bad. If I had grouped them maybe 0 to 49, 50 to 99, those bins are so large, I'm not really retaining that much information. It'd be sort of like splitting the visible light spectrum into just things left of green and things right of green. It wouldn't give me that much information. So you do need to choose a bin size that makes sense. Small enough that you're not losing too much information, but big enough that there's a point in doing it. You don't want to have a separate bin for every number because then you might just use discrete numbers instead.